Hi, I'm John, and I'm here to talk about the future of AI and crypto. So, generative AI, how it is today and where it's headed. So, we're going to first start with a basic summary of where things are today, and then talk a little bit more high level, where things are going, the big picture ideas, and a couple different concepts of how AI is being used, and just kind of brainstorming where the different possibilities could be. So who am I? My name is John. I've been involved with startups for quite a long time. Bitcoin 2011, so 12 years now. And yeah, I'm a big Rust fan, smart contracts in CosmWasm, and now I've switched over to the dark side to use AI. So what I'm working on today is using AI to find smart contract vulnerabilities. And on a high level, it's basically turning security into a compute-bound problem. So imagine you're a bootstrapped startup, and you have a couple contracts, but you're not able to afford $100,000 for a formal audit. So you can scale up your security, just get what you can afford, get like a basic continuous scan. And then if you're a bigger project like Optimism, you can afford to throw in like $1 million of compute and get a more robust audit, continuous audit. So where AI is today, it's pretty impressive, but the thing to keep in mind is the rate of progress is not slowing down at all. And there are a couple examples I want to show you. On the left, it's March 2022 from Midjourney, and then just 1 year later, the same prompt, March 2023. And this is not slowing down at all. In March 2023, you can still see some figments. So like Obama's hand is out of proportion, and Donald Trump's hand here, it's small, but it has the wrong number of fingers. And then this is a more recent example, alpha geometry. So the previous state of the art was solving 10 problems. And with alpha geometry introducing generative AI models into their framework, they were able to solve 25 problems. So this is almost as good as the gold medalist for IMO. And that's considered expert level and almost master level. So you can see in the future, even next year, it could actually surpass human capabilities for geometric proving. So where are things going? Well, first you need to look at where things are going with the underlying hardware. So NVIDIA, they first started releasing chips like once every 2 years, once every year, and you can see it's completely accelerating. So in 2024, there's 2 to 3 chips coming out, and 2025, it's not really slowing down. So how did they do this? They actually used AI to increase the feedback loop. So they're using something called ChipNeMo to improve the chip designs and make it much faster with performance and power consumption. And in the far future, we're going to see AGI, and in the kind of far future, we'll see AI autonomous agents. And where does this marry in with crypto? So I see AI agents as needing to be sovereign, so they're going to end up using crypto. They'll need the same kind of properties that we use crypto for. So decentralization, censorship resistance, and code is law. So when AGIs are operating in the different systems, you're going to see that they want to operate in a stable operating system. So they don't want something shifting around a lot. So code is law is going to be one of the important pieces. And also, we're seeing that it's going to solve the coordination problem. So AGIs and AI agents, they're able to take on different types of personas. So imagine in a blockchain, you have validators, you have developers, users, investors. So using different types of profiles, you're able to come up with some sort of baseline coordination equilibrium. And I see it as being able to solve a lot of the problems with DAOs right now. So DAOs and governance problems. So basically, like, you always have some sort of agent acting on your behalf, and you don't really know if there's conflicts of interest. So with an AI agent, you can look at the code and see how it's going to behave in a very predictable way. And like I mentioned before, you can have multiple personas taking on different types of roles. And the big thing that I see is avoiding the Moloch trap. So you can recognize when a system is approaching a poor equilibrium and suggest systematic incentives to change that equilibrium level. So because this is decentralized AI, here are some very specific examples that can actually be implemented in a couple days, like for this hackathon. So the first couple are more like avoiding scams. So, you know, if you have like osmosis.zone and then there's osmosis.cm, then it can redirect you to a wallet draining application. So there's all these kinds of things that we could easily implement with some simple AI agents. So like scanning for content, seeing if this is like a scammy governance proposal or like a low quality governance proposal, scanning code bases to see if there are vulnerabilities in that code. Like, is this a wallet draining contract? And then double checking online reputation. So there's other things too. So you can like do a complete retrieval of the proposal's transaction history, their previous proposals, and looking at how those past proposals, if they passed or if they didn't. And then you can use that to see if this current proposal, like what's different about it to produce a different outcome. And yeah, so you can generate different arguments from different personas, like how will increasing the validator set from 100 to 200 change performance, change it for users, change it for validators, decentralization. And you can also aggregate like the different documents, different protocols to pull up the relevant information that's in context to make, to have more information to make a more informed decision. And the cool thing is you can borrow from already existing concepts from machine learning and software engineering. So one of the big problems with generative AI, you can prompt something, but the output is not really consistent. So one thing you can do is structure the output to constrain it into, say, like JSON format or a Boolean. And if the JSON format is not correct, like it doesn't pass JSON linter, you can do self-healing and then improve it, make it a valid JSON. And a couple other things like improving the data set, improving self-valuation, so then these models continuously improve over time. And some other high-level ideas, if you have blockchain protocols, you can build in specific incentives for AI agents to solve different types of coordination problems, and also solve for different types of performance. So you might want something that's really fast, something that's very accurate, something that doesn't lie to you and hallucinate. And there's a lot of different properties that you can get if you incentivize agents properly. And more recently is the BitTensor subnets. So Mouse Research, they revealed that there's a big benchmarking problem where people are using benchmarks in their training data, basically giving the answers to these different models. So the benchmarks that you see on popular websites, the rankings are off. So Mouse Research is using this private subnet with more private benchmarks, so then you can have better evaluations on models. And with this proliferation of data, both text, image, and video, you're going to see what I view as licensing and copyright, either two outcomes. One is it becomes completely obsolete, or it becomes enforced on chain. And another kind of idea like ZK, fully homomorphic encryption, so you can do provable training and inference on a particular given model. And it's not just using blockchains themselves, it's also using blockchain primitives like NFTs and swaps. And I think we're going to see a lot more of that in the future. And this one last point, it's really important. So when you're trying to do something in crypto, sometimes it's pretty hard. Like if you have to do a bunch of bridges and swaps and have enough for gas fees, so you can simply give your intent to an AI and give that AI execution rights. And that simplifies the UX, so then a lot more people can be using crypto. And here are some more resources for you to read up on. And if you have any questions, just hit me up on Twitter. Or you can ask now too. Yeah.
So I was playing with Adobe Firefly, and I just for fun, and on it was like, oh, you can't use this image for like, your company or something like that. I didn't, but I was just like, how the hell would they know? Like, there's no way they can know. Am I right about that, or like, did they code?
So Adobe Firefly, they try to remove copyright images from their training set. So that's kind of how they do it. But yeah, they wouldn't really know.
It's like impossible to determine.
Yeah.
Yeah.
Yeah, good to see you here.
Yeah, good to see you.